Hi guys, this is SuperTestNet, and today I just wanted to show off my latest invention. This is the Bip157 Playground, and I want to tell you about it. So there's a very brief sentence here that gives an overview of what it's for. Bip157 is a BIP that was introduced to Bitcoin in 2017 that allows you to explore the history of Bitcoin addresses with more privacy than you can get with traditional methods of doing this. So I'm about to show you how it works, but before I do, I want to do a little slideshow that I made. I made a 4-slide slideshow to explain the problem and that we're trying to solve. So here's an example of a client-server model where we've got a cell phone over here. Maybe your cell phone has a Bitcoin wallet on it, and it probably doesn't have a copy of the blockchain. So it needs, if it wants to find out information like the balance of its addresses, it's going to need to talk to a computer somewhere on the internet that does have a copy of the blockchain and ask it questions like, here's a Bitcoin address, what's its balance? And so we've got a little server over here who receives that query from the user, and then he replies and says, the balance of this address is 20,000 Satoshis. So that's a traditional client-server model. That's how we often do things in Bitcoin if we're running a light client. You don't have a blockchain, someone else does. You ask them for information about your address. Sadly, this has privacy implications. So for example, the server might say, tee-hee, the client doesn't know that I'm logging his data and selling it. So what data does he know? He knows what Bitcoin addresses you're interested in because you sent them to him and said, what are the balances of these Bitcoin addresses? He probably knows your IP address. Because computers talk to each other using these strings of data that you pay for from your internet service provider, and there's billing info associated with that, so maybe he can purchase that from them with some kind of data sharing agreement. So you might know your IP address, unless you're using something like a VPN or Tor. That's just kind of a thing you leak when you browse the internet or use things that query other servers on the internet. And he knows the time of day. He knows when you made these queries. So maybe he can figure out your general location based on that, or what time zone you live in. And once he's collected all this information, he can make a profile about you. He can say the user with this billing address and the user who's in this time zone is interested in the following Bitcoin addresses. This is the amount of money in them. And then he can sell that data to corporate surveillance firms and other people, and it's bad for your privacy. So BIP157 was introduced to fix this in Bitcoin and make it so you can run a light client that doesn't send your Bitcoin addresses to a server. Instead, you ask a server for blocks. You say, for example, here, the phone would say, tell me blocks 5, 7, and 32. And the server would then reply with those blocks instead of with information about your specific address. Once the phone has the blocks, it can parse them, because there's a bunch of transactions in every block, and look for the ones that send money to one of its addresses. And that way it doesn't have to tell the server what addresses it's interested in, just the blocks. And that's much better for your privacy, because a block has thousands of transactions in it, and likely a server's not going to know which Bitcoin addresses you're interested in within that block. So he still knows some information. He probably still knows your IP address. He probably still knows what time zone you're in, if he can, check when you're typically making these queries. But he doesn't know which addresses you're interested in, and that's an improvement. His profile on you will have less data in it for him to sell on you, and that's good. That's a good thing. So that is what BIP157 is for, and that's a little slideshow. Now I'm going to show you how it works. So the first thing I'm going to do is click Synchronize Headers, and then I'm going to tell you, while it's doing that, a little bit about what headers are and what we use them for in the BIP157 protocol. So what the overall way that BIP157 tries to achieve, telling you which blocks to be interested in, is through something called compact block filters. Compact block filters are kind of like a summary of a Bitcoin block. Every Bitcoin block has thousands of transactions in it. A compact block filter is a small piece of data, usually about 20 kilobytes per Bitcoin block. That's much smaller than a Bitcoin block. Bitcoin blocks are typically on the order of 4 megabytes, so 20 kilobytes is much smaller than that. So it's got about a 20 kilobyte file that has to download for each block, and inside of that file, what's in there? Well, it's a compressed list of some of the information in a Bitcoin block, specifically the Bitcoin addresses that sent money in that block and the Bitcoin addresses that received money in that block. And this list is then compressed so that to make it much smaller than the full Bitcoin block. So you receive that information, and now I'm storing some of that information. But you download some of that information, you store that information, and thankfully This is a one-time thing. Your device would probably do this on startup. It would need information about the blocks that are in the blockchain. And once it has that information, then it can do queries. But yeah, it's a one-time thing. You don't need to get blocks every single time you load the page. Or at least you don't need to get the full blockchains, a summary of the full blockchain every time you load the page. You just get it one time and then it'll save it in your browser's memory. So now I'm on this page where it's asking me to enter a Bitcoin address and something called a start height. I'll tell you what that is in just a minute. But I do want to show you, if I refresh this page, if I go back to the beginning, it's useful to know that I don't have to sync the headers every single time. I've already synced them one time, and so if I go down here and click sync headers again, it'll just inform me, you don't need to do that. Your browser already did it, and we saved the block headers in your browser's memory, so I don't need to do it again unless I can skip straight to this part where we actually check the Bitcoin address. Now, I mentioned we're going to get compact block filters, and that compact block filters are a summary of a Bitcoin block. That's not the same as a header. What we downloaded before in the headers gets us metadata about each block, like the timestamp of that block and the hash of the previous block and some other information like that. Those are what we download in the headers. We use the headers as a key for the decryption, or not decryption, but for the decompression. With the algorithm we use to compress the sending addresses and the receiving addresses in each block requires a decompression key, and the decompression key is based on the block header of each block. So that's why we needed those block headers. Now we're going to search for the history of this Bitcoin address. I just hard-coded this one in because it happens to have some history and I know that it works and I've been testing with it. But you can plug in any Bitcoin address here and it should work just fine. Although this is really the only one I've tested, so who knows. Then we need something called a start height. And a start height is the block height from a time, well, I say just before you created that address. Realistically, you can do just when that address first received money, but I'm going to say I recommend doing a little buffer so you get just a bit before that. So I'm going to hit submit, and then I'm going to tell you what we need the start height for. And so the start height limits the amount of checking we have to do. We don't have to check addresses or check the blocks that came out before our address even existed. We don't need to check them to see if our address received any money in them, because it can't have. It didn't exist yet. So that's what the start height is for. It limits the amount of searching we have to do. Also, you don't have to have the user remember their start height. You know, I have the user type it in here because this is just a proof of concept. But in a real implementation of BIP157, on startup, the first time your device would get the current block height, and then it would just remember that's your start height, and it would be invisible to your user. But here, yeah, I did it the hard way, and manually typed in or actually hard-coded in a block height when I know that address first received money, and now it's checking the block filters for every block since that time. And the important thing is, all the data that it's queried from the server about, everything it's asked the server is public information. It has nothing to do with your specific Bitcoin address. It's asked it about block headers. That's public information, no identifying information about your address. It asked it for block filters, which are the compressed list of addresses that sent and received money. Those don't contain any identifying information about your address. That's thousands of addresses are in those things. And now it's downloading specific blocks that your own device, your browser in this case, identified. This block does contain a match. It contains my Bitcoin address as either a sender or a recipient. So if you scroll down this page, you can see there is now a list of blocks, and it's downloading the transactions in those blocks where the Bitcoin address I'm interested in sent or received money. And as soon as it's done with that, which it's very close to done, then we will get a final. It'll actually sum up in those Bitcoin transactions all the times it sent money, all the times it received money, subtract them, and it will learn, oh, the address currently has 0 Satoshis in it. But just as an example, this block here, block 909124, happens to be the first time this block received money. We can see now on this server, see this how it ends in 4UAM. That is the same here as the address I queried, 4UAM. That's the address I'm interested in. We can see the first time it received money here was there. It received 104,000 Satoshis. So now I did not, here in this, by clicking this transaction, I've now told the server I'm interested in this one, but I didn't have to do that in my browser. when I downloaded this stuff, my browser was downloading the entire block and was able to figure out what's the balance of this address and what this specific transaction sent it without needing to query the server for the transaction. I just queried it for the block. So then I clicked this just to confirm, but you wouldn't do that in a real implementation of this because you already have the information. You don't need to go to a block explorer for it. Yeah, so that's pretty cool. And if I just want to confirm and check the balance of this address on this server, you can see that it currently has a balance of 0, so it matches what my little Bip157 thing is showing, but my Bip157 thing does it privately. It doesn't tell the server which address I'm interested in, because it just says I'm interested in these specific blocks after finding out which blocks it's interested in using filters. So yeah, that's what this little GitHub project is for. If you're interested, you can go to this website, the Bip157 Playground. You can do what I just did, explore the history of Bitcoin addresses in a more privacy-preserving way. You can learn about Bip157 filters and the stuff that I've learned while making this app. And of course, you can check out my GitHub. All the code is free and open source. Here it is. If you click the HTML file here, it's about 650 lines of code that get this thing working. And maybe if you're making a Bitcoin wallet and you want to respect your users' privacy, consider using Bip157 and the tools that I've compiled for you here. Check them out and see if you want to use those in your projects as well. Thank you so much. This is Super Testnet, signing off.